Hey there, welcome to Charger Games. My name is Raja and this is the third episode of how to create Android games with Unity. So in the last two videos we have actually set up our development environment. In the first video we have actually downloaded and installed Android SDK, and the second video we have set up the Unity remote. So in this video we're going to finally learn about the touch controls in Unity. Now this video is going to be very basic. We'll start from the very basics of touch and how we can take touch inputs in Android, and in later videos we'll learn about the more complex concepts. Okay, so this is going to be very simple. So let's get started. Now before starting, you should already have a Unity remote set up on your device. Okay, so you have to use the Android device to test the touch controls here. So in the last video I have actually showed you how to set up the Unity remote. So if you don't have a working Android device and you don't have the Android SDK set up for this tutorial, you have to set things up. So you should watch the previous videos first, set your device, set your development environment, and then you should watch this. Okay, so let's go and start this. So in this video we're gonna actually test the touch controls inside our Unity remote or inside our Android device, and those things will get where actually we are touching, and we'll print the positions by using debug.log into our console. Okay, so first of all, just connect your Unity remote or your Android device via USB to your computer and just turn on the Unity remote. So next thing we're gonna do is we're gonna create a simple empty game object, and we're gonna name it touch test. So we're gonna attach our scripts to this object so that we can actually test those things. So let's create a new script, add component, new script, and I'm gonna name it touch test. Create an add. Now let's go and open it up in MonoDevelop. Okay, it's opening. Okay, here we are. So very first thing we have to do is you have to know that before doing this we have used a lot of input controls. Okay, but for doing those input controls we have used our keyboards as our input device. Okay, so while using our keyboard we have used everything inside this input class. Suppose we have used input.getButtonDown, or we have used input.getKey, or we have used input.getAxis. Okay, so every input that we can take within Unity is inside this input class. So the same way the touch input controls are also inside this input class. So whatever we want to do, we have to do inside this input class. Okay. So the very first thing we're gonna learn about touches is something called touch count. Touch count is a static variable that is inside this input class, using which or within which the number of touches that is occurring currently in your device gets stored. As an example, all of the devices currently supports multi-touches. Okay, so suppose I am actually currently touching one of my fingers on the Android device. So then the touch count variable, the value of the touch count variable inside this input class will be 1. When I'm touching two fingers, then the touch count value of the touch count will be 2. Okay, so the same way the touch count actually stores the number of touches currently occurring on your Android device or your iOS device or any kind of touch device that you can connect. So in order to check that out, let us debug.log. If you don't know, debug.log just prints out whatever we just pass inside it, inside our Unity console window. So using this we can actually print anything. Okay, so here we're gonna print input.touch count. As I've said you before, that touch count, input.touch count basically is the number of touches currently occurring in your device. So let's go and test it out. So if I go here and play it now after playing, you just go to window and click on the console here. So inside this console we can actually see whatever is getting in. As you can see, right now it is printing 0. That means the touch count is 0 since I'm not touching anything. But if I give a finger on my Android device, I'm giving it, and as you can see it says 1. If I give another finger, it says touch count 2. If I give another finger, it says touch count 3. And as you can see, right now I'm touching only one finger. Right now I'm touching no finger, so as you can see the 0 is getting updated. And if I pick one finger, this is getting updated. If I put two fingers, as you can see, this thing getting updated. That means there are two fingers currently. That means the touch count is 2 right now. And if I put 3, as you can see, the touch count 3 is getting updated. That means right now the touch count is 3. So using this, we can know how many touches are currently occurring in the device. Okay, so that's a very simple thing. So let's go and learn something more. So this will be helpful whenever we want to actually test if a touch is actually occurring. So before testing any touch controls, very first thing we're gonna do is we will check if touch count is greater than equals 1 or if touch count is greater than 0. That means if there's a touch, if I'm touching something, only then we'll check touch inputs. Otherwise we'll not waste our time by checking the touch inputs. Okay, so that will save us a lot of computations inside this update method. So first of all, we'll say if input dot touch count greater than 0, that means that there is actually something touching. If it is 0, that means nothing is touching. Okay, so if it is greater than 0, only then we will test touch controls. Okay, so the next thing we're gonna learn is we're gonna learn about something called an array of touches. Okay, so inside Unity there's a specific structure or specific data structure called touch. This touch structure stores all kind of touches that occur in our device. Okay, so when a touch occurs, it is actually type of those touch structure and it is getting stored inside an array called touches. Okay, so touch is a data structure that stores all kind of touches, and this touches data structure actually stores all kind of touches that is occurring in your device. By all kind of touches, I mean the position of the touch, the phase of the touch, the other properties of the touch. Okay, all these things are stored inside this touches array. So if we want to get any of those touches, or if we want to get if we want to know about any of the touches, we have to get the touches from this touches array. Okay, so an easy way to get that is by using a function called input.getTouch. So input.getTouch gives us access to any of the touches by using that an index number. So as you can see here, that inside that we have to pass an index number. If we pass 0 here, 0 means the first element of that touches array. Okay, so input.getTouch 0 will return us the properties of the very first touch that is occurring in our device. If we pass input.getTouch1, this will return us the properties of the second touch that is occurring in our device. Okay, so this is returning the first touch, input.getTouch0, and using a dot separator and writing the position, we can actually get the position of the touch. I told you before, every touch has specific properties like position, delta position, finger ID, and also phase, all that stuff. So first of all, we'll learn about the position. Okay, so using this position, input.getTouch0 position will return us position of the very first touch that is occurring in our device. So let's go and print this thing using debug.log. Debug.log input.getTouch0.position. So what this will do is, this will take the very first touch that is in 0 index, and it will take the position of that, and it will print that in our console so that we can see that. So let's go and test that out. Now here I'm gonna press play, and again I'm gonna go to window and press on console so that we can take out the console. Now if I just go ahead and just touch here, if I touch here, as you can see, it just prints the position of the touch. Okay, it prints 82.9. This is the X component of the X position of the touch, and this is the Y position of the touch. If I touch in any other place, as you can see, it prints a different thing. Now if I if I touch my device with a finger and then I put another finger, it's not gonna just print both of those things. It's only gonna print the very first touch. Okay, because we have told it here that we want only the very first touch, nothing else. Okay, so that is why it will always print the very first touch that is occurring. Okay, hope you got this. So next thing we're gonna do is we want to learn how we can get to know about all the touches that is occurring. In this way we will learn about only one touch, but there's another way by which you can figure out all the other touches, all the touches that are currently occurring in your device, and we can get all the positions of that at one time. Okay, so in order to do that, we're going to use a for each loop. For each is a very simple loop. If you don't know, just check out some of the Unity official tutorials. For each loop just iterates through each thing, iterates through each element of an array or collection, and then prints or returns us those values, or we can store those values inside some instances. As an example, here we want to store the touches, so that is why we are creating a touch variable. Okay, so this touch variable is of type touch. Okay, so this is an instance of this touch structure, because we want to store touches, so that is why we're creating instances of those touch structure. Okay, so touch in input dot touches. So that basically means, I told you before that this touches is actually, as you can see, an array of touch variables or touch structures. This touch stores array of touch structures. So for every touch inside this touches array, we want to store that touch inside this touch variable, and then we can do whatever we want with that. So here we will debug.log, the position of that touch. So what this will do is, this will iterate through all the touches that are currently occurring in our device, and it will take the position and then print that out. So first time it will take the 0 position touch, then it will store that inside this touch variable, and it will print the position. It will do the same thing for all the touches, and when the touches have been finished, it will no longer print. So let's go and check that out. So okay, I haven't actually stopped this thing. Okay, so let's play and bring the console here. So if I touch here, as you can see, there's only one touch currently, so it is printing only one. If I go and put all my fingers, all the touches are currently getting printed. If I use more fingers, more touches are getting printed. Actually, you guys can see this, but since this is too fast, you don't have any idea what is occurring here. So if you take a look at here, as you can see that all the touches are in different positions. This touch is here, 285, 232, and this touch is 393, 140. This is here, this is here. So that basically means all of these are different fingers that are actually touching the device. That is why their positions are different. So in this way, we can actually print all the touches that are occurring. Now if I'm teaching you how to print, that doesn't mean that you can't do anything else. I'm showing you actually the simplest way to know about the touches. In later videos, we'll do a lot more things with those touches. Okay, so now you know how to get those touch inputs and do anything you want with them. Okay, so I think I want to teach one more thing in this video, and that is the touch phases. Okay, the touch phases are quite interesting things. A phase of the touch actually determines the phase of the touch. I don't know how to put that. A phase of the touch actually determines if the touch has just begun, or it has ended, or it has cancelled, or it has actually currently occurring. Okay, so the state of the touch determines the phase of the touch determines the state of the touch. Okay, so using the phase we can see if the touch has just began. That means whenever we first time touch the screen. If the touch has ended, that means we have lifted our finger from the screen or our device. Or the phase is moved, that means we are actually moving our finger. So using the touch phases we can actually figure out all those things. So let's go and check that out. Let's try to see what is happening. Okay, so here we're gonna print if input.accelerometer is greater than 0. That means when we are touching this, we wanna print if input dot get touch 0 dot phase. That means the phase of the touch equals to touch phase dot began. That basically means that the touch has just began, or the very first time we are touching the device, the phase is began phase. Okay, so here we're gonna print touch begins or touch began or whatever. Okay, so the same way we're gonna just copy and paste it below. So here we're gonna say if the touch phase equals moved. That means whenever we are moving the finger, and we're gonna print moved. The same way here we will see it's just ended. We will say touch ended. Okay, so using these things, whenever the touch begins, it will print out the touch has began. Whenever we are moving the finger, that is the touch phase is moved, it will print touch moved. And whenever the touch phase has ended, that is we have actually lifted our finger from the screen, it will print touch ended. So let's go and test it out. It's very interesting. So again, I'm gonna play it, and I'm gonna put the console here, or bring the console here. So as you can see, when I first time just put my finger here, you can see that it has touch began and it is said touch moved, because it is impossible to put your finger without moving. Okay, so that is why it is saying moving, but I'm not actually moving my finger. Now if I lift my device, lift my finger, you can see that touch ended. Okay, so very first time if I put my finger, it says clear that. Very first time I put my finger, it says touch began, and I lifted it at once, so that is why it says touch ended, and there was nothing moving, so that is why no movement. Okay, so clear that. Now this time I'm going to move my finger. Okay, so as you can see, I'm touching the finger, so it says touch began and touch moved, and now moving the finger. So as you can see, the move is getting updated and the began is not getting updated. I'm moving my finger all over the screen of my Android device, so that is why you can see the move has been ended. Now I'm gonna lift my finger, and you will see that touch ended phase will be get printed. So 3, 2, 1, lift my finger, and you can see the touch ended phase has started. So this is the way how we can know the various properties of touches. Now don't think that these things are not important. These things are very, very important, because using began phase we will learn how we can do thing only one time. As an example, suppose you wanna shoot, when you touch the device, you want your player to shoot. So you don't want it to shoot as long as you touch the device. You want it to shoot only one time whenever you touch for the first time. So then you will check if the touch phase began, that is the first time you have touched the device, then it will shoot. Or using the moved, you can actually move your player or whatever thing throughout the screen. We will learn how to do all those things in later videos. We'll learn the applications of these things. This video was quite introductory, but I think you guys will find it quite informative, and If you really like this video, please hit the like button and make sure to subscribe to my channel to get all those videos. I'm uploading new videos every day, and if you like this video or hated this video, just write a comment and tell me what you feel about this video, if you liked it or hated it. So thank you very much for watching this video, and I hope you guys enjoyed this tutorial. Thanks a lot for watching and have a great day. Hello and welcome to Charger Games. My name is Raja and this is another Unity Android game development tutorial. So in the last video we have learned about the very basics of touch controls, and in this video we're going to learn about more advanced touch controls, because in order to work with Android we need to learn more about the touches. So let's take a look at what you're going to be learning in this video. So let me go ahead and play this scene. As you can see here, we have a lot of cubes in the scene. So what you're going to be doing is, whenever I'm going to touch a cube, it's going to be destroyed. I'm touching a cube from my Android tablet, and if you take a look at the scene view, I'm casting a ray that is colored red. A red colored ray from the camera to this object or the position where I'm touching, and then the ray goes and that thing gets destroyed. I'm drawing that ray so that you guys can understand where actually I'm touching on the screen. So as you can see, if I touch this cube right now, the ray goes and the cube gets destroyed. So for this, we have created a simple touch tester script, and I have also created something so that the ray gets drawn like this. So we'll be learning all these things in this video, and it's going to be very helpful. So let's get started. So first of all, let me tell you that I have this time created a 3D scene, okay, because we're going to be testing it in 3D. So I have created a 3D scene, and let me go ahead and create a new scene right here. So new scene, here's my new scene. Let me go ahead and save it. Just 2. Okay, so this is my new scene. Now what I'm gonna do is, let me go ahead and create an empty game object here, and I'm gonna attach all these things in this empty game object, and I'm gonna name it touch tester. Let's from here just select it and attach an icon to it. Let me select the orange one so that we can actually see where the touch tester is. I don't think it really matters, but this is for the sake of this. Okay, so now we're gonna attach a script to the touch tester that is gonna take care of all the touch controls or all the touch controls that you're gonna test. So let's go and create a new add component, new script, and let's name it touch test. Let me go ahead and create an add. So let me open it in MonoDevelop. Okay, so first of all, let us understand a bit what you're going to be doing here. So I'm going to touch different positions on my Android device's screen. So what will happen is, in the previous video we have learned how we can take the position of the touch. So we already know how we can get the position where we are actually touching. But in order to collide that touch, or in order to get the information that if we are touching on some objects, suppose I have created some cubes, and if we want to get the information that my touch is actually touching that cube, or my touch is actually colliding with the cube, in order to do that we have to do a lot more things. So in this case we'll use a property called ray casting. Ray casting means creating and casting a ray from a certain position towards a direction of a certain length. In this case we will create a ray of infinite length from our camera to the touch position on our screen. So what will happen is, a ray will go from the camera to the position where we are touching on the screen, and then if the ray collides with an object, so that means there's an object at the position where we are touching, so that will destroy that object. That's what we're gonna do in this video. Okay, so our first step is to get the position where we are touching on the screen. So let me go ahead, and we already know how to know where we are touching on the screen. So in order to get the position of the touch, we have to write input dot get touch 0 dot position. Now if you don't understand this thing what I'm writing, I have explained all these concepts very in depth in the previous video, so I would request you to check out the previous video so that you can understand all these things. Okay, so this is how we are actually getting the position of the touch or wherever I am touching. But the problem is if we want to cast a ray from the camera to this position, then we have to convert this position to a ray. Okay, so there's an inbuilt function of our camera that can convert this thing to a ray. So in order to convert this position to a ray, in order to convert this touch position to a ray, we have to write camera dot main dot screen. Here you can see there's a function called screen point to ray. So if I go and select that, so what that means is inside that function I am putting the position or the touch position, and this is basically converting from screen point to a ray. Okay, so this is taking a point on our screen and then it is converting that to a ray. Okay, so now we have to store this ray inside a ray type of variable. So let me go ahead and create a special variable of type ray. So write ray, and inside this ray we are going to store this ray that we are getting from the touch position. Okay, so now next thing you have to do is we have to do something called ray casting. By ray casting, we will cast a ray from our camera to the touch position, and we'll take a look at if that ray is colliding with any object. And if the ray is colliding with any object, that means we are touching something, and that is when we'll debug log a message writing that it touched something. Okay, so in order to cast a ray, we have to write physics. Since it's a physics property, so we have to write physics dot raycast. And if you can see here we have 12 different kind of functions or 12 different kind of functions for this ray casting. So among these we're going to use I think this one. Okay, you can use this one first, or probably okay, we're gonna use this one first. So I'm gonna, as a first parameter, we have to pass the array that we want. So I'm gonna pass the array variable that we are creating here. As you can see, from the touch position, we're getting this array, and we're gonna pass it here. And in the second variable, we're gonna pass how much of length we want the array to be. So we want the array to be of infinite length. So I'm passing mathf dot infinity. So that means we are creating an array that's infinite length, that's of infinite length. Okay, so what this function raycast does is it takes this ray and this distance, and then it creates an array from the camera to the touch position, and then it returns us if it has collided with something or not. So it returns true or false. So we have to check if physics.raycast. So inside if block I'm checking this. That means if it has hit something, it will return true, and if it hasn't collided with something, it will return false. So if it has collided with something, that means if it returns as true, then we're going to write debug.log hit something. Okay, something, I spelled it wrong here, hit something. Okay, so here this will just cast a ray from a camera to the touch position, and then if it collides with something, then it will write hit something. So in our scene, let me save the scene, and in our scene let me create some 3D object cubes so that we can actually check if it is actually touching something. So let me go ahead and duplicate this cube and place it all over the place. so that we can check from different angles. So first of all, let me move the view a bit because I can see my camera. Where is my camera, by the way? Okay, let me go ahead and move to this view. I think it would be better. Okay, put it here. Again, duplicate it. This time put it here. Again, duplicate it. This time put it right there. This is only so that we can actually test the different kind of touch controls here. Okay, right now as you can see the cubes are pretty in different positions, so let me go ahead and align it with the camera view. So select the main camera, go to edit. Oh, how I forgot where that thing is. Okay, let me go to game object and write align with view. So what that will do is this will align the scene view to the game view. Okay, so now it looks like this. So now since all of these cubes have a collider already attached to them, as you can see a box collider is attached to them, so if a ray is casted from the camera here, if I move the view a bit and select the camera, if a ray is casted from the camera to these objects, so the ray can be collided with these objects since they have already a collider attached to them. So if the ray gets collided with the objects, it will print on our console that it collided with something. So let me go ahead and play this scene and see what is going on. So as you can see right now the scene is going on. Okay, and if I touch this object here, as you can see I'm touching this object and it is saying that hit something here. And again if I touch this object it says hit something. If I clear it, again if I touch it, it says hit something. Okay, so now we can see that actually we are testing the touch controls and you can see that we are actually hitting something. And here we got an index out of bounds error. We're gonna fix that right now. So stop display mode. This is giving us an index of out bounds since we are only checking the zero touch position here, but there we are touching more than once here. So let me go ahead and put a condition here. If input dot touch count is greater than 0, that means if we are actually touching the screen, and then I want to check what I'm doing right now. No, and then we're gonna check input dot get touch 0 dot phase equals touch phase dot begin. Then we want to check all these things here. Okay, okay. If you are not understanding what I'm writing here, please make sure to check out the previous video because I have discussed all about these things there. So here we are checking if input touch count greater than 0, that means we are actually touching the screen, and the touch phase is began, that means I have just touched the screen. I am not touching it for a long time. Only then we're gonna check all these things. Okay, so right now, as of now, we have the ability to check if we can touch an object. So next I'm gonna draw this ray by using debug.drawRay so that you guys can see clearly where the ray is coming and where it is going and when it is printing touched. So write debug.drawRay, and here I have to pass a start point where I will pass ray.origin, not this kind of ray, it's small ray dot origin. So this will be the origin point of the ray, so from where the ray is starting to ray dot, oh not this ray dot ray dot direction times, let's say we wanna pass it up to 20. Okay, 20 times long. So what we're doing here, we are drawing the ray that we are casting from the origin position of the ray, so from where the ray starts towards the direction 20 units apart. So we are making the ray 20 units long. You can make the ray short, but I'm just making 20 so that it gets long enough so that we can actually visually see it on the screen. So now you'll be able to see the ray and your doubts will be clear. Where is parsing error here? Line 26. Where is that? Okay. Okay, I have missed a curly brace here. I think now everything is okay. Okay. So now this time if I okay, so let me also give this ray a color so that you guys can see it. So at the third parameter you have to write color dot red. So now what will happen is a red color ray will be fired. So let me go ahead and run it right now. And this time if I okay, this ray exists. This time if I touch a position, you can see a red colored ray gets casted and it says hit something. If I clear it again and touch this cube, the ray goes from the camera to this cube here and it says touched. Okay, and if I touch somewhere else, the ray goes but nothing gets printed. Only if I touch the cube at that time, as you can see, I'm touching the cube this time. If I clear it, I'm touching here and there and nothing gets printed because we are not colliding with anything or we are not touching anything. But if I touch the cube, as you can see, the ray goes from the camera to the cube and this time it says hit something. Okay, and it is hitting again and again and again. So this is how we actually test the touch controls and how we are actually, if we are actually colliding with something with a touch. Okay, so next what we're gonna do is we have one more thing to do. Now this time what we want to do is, if we are touching this cube, we want this cube to be destroyed. Okay, so if we want the cube to be destroyed, or if we want the object we are touching to be destroyed, then we have to get the information of what we are touching, or I'm sorry, what we are hitting with the ray. Okay, so if we want to get information about what we are hitting with the ray, we have to create another type of variable that's called raycast hit, and let's name it hit. So this variable will take care of the things that the ray hits. Okay, so this hit or this raycast hit stores information about the object or anything that the ray hits. Okay, so if we can access to that object which the ray hits, then we can destroy that object, move that object, or do whatever we want to do with the object. Okay, so as you can see here, here we are casting the ray and we are getting information about that. Next, what we can do is, this time we'll use another variation of this function. So this time we'll say ray, comma, and then as a second parameter we have to use this hit variable. Okay, so if we use this hit variable and put the word out before it, if I write hit and put the word out before it, so that means we will get all the information about the object that has been hit inside this hit variable as an output of this function. Okay, so that we can check about the hit variable in the next frame or in the next statement. So next parameter we'll pass is, let me see, next thing I think we'll pass the distance of how much we want to cast the ray. That's method.infinity. I think this version is good, so we're gonna pass math f dot infinity, and by this thing what will happen is this time this will cast a ray from the origin position to wherever we are touching in infinite way, or in of infinite length. It will cast a ray of infinite length, and if the ray hits something, then it will store the information about that object inside this hit variable. So now we can get access to that variable by using this hit variable. Okay, so now if we want to destroy that object which we are hitting by touch, we want to say destroy hit dot transform dot game object. So this way we can destroy the variable that we are actually hitting. Okay, I hope you guys got it. I will explain more about these things after we test this thing here. So this time let me play it, and if I play, and this time as you can see, if I touch this cube, as you can see it says hit something and it got destroyed. And now if I touch this cube again, the ray goes and it gets destroyed. If I touch this cube, ray goes and it's destroyed, and again the ray goes and it gets destroyed. So this is how we actually get access to the objects that we are hitting by using ray casting, and then we are getting access to that object by using this hit variable, and then we are destroying that object, or we can do whatever we want to do with that object. Okay, so let me go one more time through all these things that we have done here. So first of all, we are creating a ray by using the position where we are touching on the screen and converting it to a screen point ray, and then storing it into the ray function, a ray variable. Then we are drawing a ray so that we can visually see where the ray is going. Then we are doing ray cast and passing the ray here, and we are checking if the ray is actually hitting something, and if it hits something, then it will put information about hit object inside this hit variable. And then we are getting access to that object which has been hit by using hit.transform.game object, and we are destroying that. So I hope it got cleared. I know it's pretty confusing, and I try to keep it as simple as possible. So thank you very much for watching. This is it for this video, and I have changed some settings of my microphone so that you don't get any noise from outside. Let me know if the sound is good or bad. And if you guys enjoyed this video, learned something, make sure to hit the like button and subscribe to my channel. So thank you very much for watching. And if you guys really enjoyed, make sure to write those in comments and let me know if you guys loved this video or hate this video. So thank you very much, and have a great day. Thanks for watching. Goodbye. Hey guys, welcome to Charger Games. My name is Raja, and this is another episode of Unity Android game development tutorial. So in the last two videos we have learned about touch controls. So in this video we're going to finally learn about accelerometer inputs in Unity. So I hope you guys are super excited as I am. So let's first of all take a look at what you're going to be building in this video. So first of all, we'll discuss a little bit about accelerometers, how it works, and then we will build something like this where we have a cube and I have my device attached to my computer, and I can move this cube left and right just by rotating my device. So by using accelerometer, this cube can move left and right. And later on in this video, we'll move something more interesting. Here I have built something airplane-like structure, and this airplane can move via our directions. First of all, let me change the code a bit. For that we need this one and this one. Okay, so this plane, what happens is I can control this plane by using my Android device, and this plane moves and rotates by using the accelerometer. So as you can see, if I move my device left, the plane loads left and rotates right according to my device, and I can move it forward or backward according to my wish. So we'll do all these things in this video. So I hope you guys are excited to build these things. So let's get started. Okay, so first of all, let me go ahead and create a new scene here. So I'm going to create a new scene. No, we don't want to save that. And in this scene, first of all, I'm going to demonstrate how you can get the accelerometer inputs from your device. So let me create a cube here. It's a simple cube, as you can see. So we're gonna modify it a bit so that it looks like your Android device. Okay, so now suppose this is your Android device which you are holding in landscape mode as seen in the video. As you can see in the video, suppose this is your Android device and you are holding it in the landscape mode. Now whenever you rotate your device, you can get accelerometer inputs on different axes. As an example, as you can see, if I just click on this arrow button here, as you can see, this is the red arrow is our x-axis, the green arrow is our y-axis, and this blue arrow is our z-axis. Okay, so if I now click on this rotate button, and if I using this blue line, if I rotate my device like this, as you can see, if you're holding your mobile device like this and you are rotating your device like this, what you're basically doing is you are giving acceleration input in x-axis. When you're moving in the left and right directions, you are giving accelerometer inputs in the positive and the negative x-axis. Okay. The same way, when you move your device like this, you are giving acceleration in the y-axis. And by these things, by rotating your device in different directions, you can get accelerometer inputs. Okay, and in Unity we can get these accelerometer inputs and use this as our input. As we can use the keyboard inputs or arrow key inputs or mouse inputs as our input, the same way we can also use this accelerometer inputs as our input variable. Okay. So with that being said, let us try to create a simple script and move a cube left and right by using accelerometer inputs. Okay, so first of all, let me go ahead and create a 3D object cube here. Here we have a simple cube. Now I'm gonna add component and I'm gonna create a new script here, and I'm gonna name it accelerometer move. Let's go and create an add and open it in MonoDevelop. Okay, so as you guys know, we have an input class in Unity, and all of our input controls comes inside this input class. So all of the functions or all of these things which help us to take inputs comes inside that input class. The same way accelerometer inputs also exist inside that input class. So how do we access that? In order to access the accelerometer inputs, we simply write input dot, as you can see, we have acceleration as an option here. So if I select that and again press a dot, now we can take accelerometer inputs from 3 axes. We can take accelerometer input from the x-axis, y-axis, and z-axis. Okay, so first of all, we're going to test the acceleration from the x-axis. Okay, so we're going to store this variable inside a temp variable. So here I am storing the value of acceleration inside a temp variable, and then I'm just gonna debug.log this temp value so that we can see how the value changes each frame whenever we actually rotate our device. So let's go and window console. Oops, I have made an error here. Float int explicit conversion. Okay, I have to make it a float value because acceleration.x is a float value. Okay, so now if I come here, the error will be gone. Now if I run this game, as you can see, here we have a different acceleration inputs. So if I move my device left, as you can see, the acceleration input is increasing. It's currently 7. And if I move it right now, as you can see, now it's positive and the positive value is moving. Okay, so now I'm moving my device left and right. And if I move in the center, as you can see, it's almost near 0. I cannot keep it completely 0 because Yes, as you can see, it just came to 0, but always it's not possible. But as you can see, if I move it to the left, if I rotate to the left, rotate it to the left, as you can see, we have a negative acceleration on the x-axis. And if I rotate it to the right, as you can see, we have a positive acceleration. Okay, hope you guys can see that. We have a positive here and we have a negative here. Okay, so it becomes clear how the acceleration actually works. I have just tested in the x-axis. You can do this thing in the y and z axis also. You can write debug and log and test these things in y and z axis for your learning. Okay, so now let's try to move this cube using this accelerometer input. So what we can do if we want to move this cube? In order to move an object, there were various options in Unity. We can move an object using various options. So we're going to use a very simple method to move our device, to move our cube. In order to move a cube, we will use a simple function called transform.translate, and inside that, this transform.translate function helps any object with which this script is attached to move in x, y, or z direction. So we are not going to use this version. If you see here, you have 6 versions of this function, and if I just select the down arrow key, we can see other functions as well. So we're going to use this function where we have to input 3 values. So here in the x value, I'm going to input temp. So that means in the x-axis, I want to move my cube by this temp value that we are getting from the x-axis of the acceleration. And as the y value, I'm going to put 0. And as the z value, I'm going to put 0 because I don't want my cube to be moved in the y and z axis. Okay, so we are getting the value of acceleration in the x-axis. We are storing it inside the temp variable, and then we are translating our cube in the x direction. I mean, we are translating our cube in the x-axis by using this value. Okay, so the cube will move in the negative and positive x-axis according to our acceleration input. So if I go ahead and run this thing now, as you can see, I can move my cube pretty much easily left and right. So this is how you completed your very first acceleration input application. Okay, you can use this thing everywhere. So let's go and take a look at some more sophisticated things. Let's build that plane which you have built. I built that plane just because it is easy to demonstrate rotation and translation both with that cube. I mean with that plane-like structure. So let's just disable this cube here, and I'm going to create a couple of cubes here. First of all, let us create an empty object. Let me call that plane. Okay, and then I'm gonna game object 3D object cube, and I'm gonna make this cube a bit long in the z-axis. Okay, just like this, and I'm gonna make it a bit thin in the y-axis, just like this. And then I'm gonna duplicate this cube, move it down below, and now I'm gonna actually instead of control key I have pressed the Windows key, so that this happened. Sorry for that. So now I'm gonna make it a bit small in the z-axis and make it a bit large in the y-axis to make the wings of the plane, and make it more small in the y-axis. Now let's move it a bit different. Okay, I think this is okay, but we can also do one more thing. We can do the tail part. Let me duplicate it, put it below, and let me put it here, and just this is a very easy way of creating a plane-like structure. Now we're gonna select all these cubes and move it inside this plane. So here we have a plane. Okay, so now we're gonna rotate this plane using accelerometer input. We have already learned how we can move the plane by using move anything by using the accelerometer input by using the transform.translate function. So let's try to rotate this plane. Okay, so as you can see here, we are getting the input in the x direction. So if we rotate my device in the left and right direction, I want this plane to move. I want this plane to rotate in the left and right direction like this and this. Okay, so in order to do that, we're going to use another function called transform.rotate. As you can see, previously we have used transform.translate. Now we're going to use transform.rotate, which is another function, and we're going to use this version where we will give three values in the x, y, and z direction. So for the x direction, since we want our move cube not to move with respect to the x-axis, now remember, previously we were translating in the x direction, but now we are rotating. So in order to rotate our plane or cube or whatever, we have to specifically tell by which axis or with respect to which axis we want to rotate. As an example, as you can see, we have our z-axis right here. This is our z-axis on the blue. So if I want to move my plane like this and this, so that means we are actually rotating around this z-axis. Okay, so this is the z-axis and we are rotating around it. Okay, and if we want to move our cube by the x-axis with respect to the x-axis, then we have to move around it. As you can see, we have this green arrow which just signifies that we are moving our plane with respect to the y-axis. And here, as you can see, here we have our z-axis, and if I select here, as you can see, the color is blue. And same way, if I click on the rotate tool, as you can see, this is the color blue. That means this is where we are rotating our plane with respect to the z-axis. Okay, so when we want to rotate our cube like this, we have to rotate our cube according with respect to the z-axis. Okay, so in the rotate function, for the x and y value we're going to put 0, and for the z value we're going to put this temp. So that means in the z-axis, according to the I'm sorry, I'm telling according again, with respect to the z-axis or around the z-axis, we want to move the plane by this value which we are getting from the x-axis of the acceleration. Okay, so we want to rotate our device left and right, but we want to rotate our plane according to the z-axis or with respect to the z-axis, since only if we rotate it around the z-axis, only then we can rotate our plane left and right like this. Okay, so now since we have written this code, let's go and try it out and see what happens. Now as you can see, if I rotate my device, okay, I haven't actually attached the script here, so let me go ahead and attach the scripts, accelerometer move. Now let's run this. As you can see, now if I rotate my device, the plane rotates exactly in the opposite direction. Okay, that's because currently, as you can see, currently I am rotating my device to the left. Okay, let me put this debug log on here so that you can actually see the value. As you can see, now the device value is negative. That means I am rotating my device in the negative direction, but the plane is moving in the right direction. But right now I'm moving my device in the right direction. As you can see, the value is positive, but the plane is moving in the left direction. So why this is happening? This is happening because when we are giving the negative value here it is coming and it is rotating according to the z-axis, and in the z-axis value this negative value becomes negative, and that is why it is moving in the negative direction when we are giving positive input and positive direction when you're giving negative input. So let me go ahead and give a small negative sign here, and now everything will be okay. Now if I run this game, as you can see, now I'm moving left, so value is left and it is rotating left. Now I'm moving right, value is right, value is positive and it is rotating in the positive direction. Okay, so As you can see, the rotation is pretty slow, so let us come and give it a simple speed. I'm gonna give it a value of 5f, and I'm gonna multiply it by speed. Now as you can see, now it behaves correctly, I guess. Now it rotates according to my wish. So let's also try to move it forward. So in order to move it forward, there were various ways to do this. So what you're gonna do is we can also of course do transform the translate. Okay, let's try that. Transform the translate. We have already done that. So here we wanna, instead of x-axis, we're gonna move the plane in the z-axis, because z-axis is the front direction. As you can see in 3D, as you can see, z-axis is the front direction. We want to move the cube, we're going to move the plane in this direction. So that is why we have to give the value in the z direction. Okay. So in the z direction, we're going to give the value temp times speed. So now this transform the translate function will move the cube in the z direction according to the value of acceleration. Okay, if we want to move this in the z direction, we also have to get the value of the acceleration of the z direction. So let's take another variable z, and inside that we're gonna input dot acceleration dot z. So now we are getting the value of the acceleration in the z-axis and putting it in the z variable, and here we are giving the z value. So by this value we want to move the plane in the z direction, or in the front direction. So let's go and run it. As you can see now, where it is gone. Actually, transform the translate moves pretty fast, so we also have to multiply it by time dot delta time. Now if we run it, as you can see, it behaves pretty good, or maybe not. It isn't behaving pretty good. Again, it is going in the opposite direction. As you can see, currently I'm moving my device back, but it is going front, and right now I'm moving my device front, but it is going back. So in order to change that, we'll do the same thing, just here we'll put a negative sign so that it moves in the opposite direction. Okay, and we'll increase the value of speed to 10 here. So now if I run it, as you can see, now our plane moves in the front direction like this, and in the back direction like this. As you can see, the control is pretty slow. You can give it more speed to make it speed it up more. Is it actually getting the speed? I'm not sure about that. As you can see, the speed is still 5 here, so let's make it 10 here. Okay, now I have a pretty good behavior of the plane. Another way to do this is to do it like this. We can do transform dot forward plus equals okay. I think this is a great way. This is a simpler way to do that. We can do that other ways too, but this is a simpler way. So this was the basics of accelerometer inputs in Unity, how we can use that, how we can use X, Y, and Z axis. I just don't want to give you basic theory. I just wanted to give you a practical example so that you guys can actually understand how these things work and how to put it into practice. So I hope you guys enjoyed this video and learned something. So thank you very, very much for watching this video and have a great day. Thanks. Hey there, welcome to Charger Games. My name is Raja and this is another Unity Android game development tutorial. So till this episode we have learned pretty serious stuff. We have learned about touch controls, we have learned about accelerometer inputs. So in this video we're going to learn about a very important topic called screen independent or screen resolution independent UI. So we're going to learn how to create UI that will be screen resolution independent. So that means if you create UI for a tablet screen or for the resolution of a tablet, it should work same for smaller screen mobile or any bigger screen devices. Okay. So we're going to learn how to create UI that can be used on any devices that will work the same on any devices. Okay. So let's first of all take a look at what we're going to be building or the result that will be achieved after this tutorial. So here I have a pretty simple scene. As you can see, you can think it of a menu scene that you have created, and in the menu scene you have this image right here and two buttons, play button, pause button maybe, or play button, exit button maybe, and there you have a back button maybe. So the thing to notice is that right now we are working in 1280 by 720 resolution. Okay, now what happens if we reduce the size or reduce the screen size of the resolution? Now you can see that if I reduce the screen resolution, if I reduce the screen size, you can see that even if the size of the screen is getting smaller, the buttons are remaining of the same size. Buttons are not getting smaller. Moreover, they're going out of the screen. Okay, so this is the behavior that we don't want. We want the buttons to be resized when we are resizing the screen, and we want the buttons to be to stay at the same place where they were at the previous time. Okay, so this is the problem, and we're gonna achieve something like this. So when we're gonna achieve something like this, where if we just resize the screen, we want the buttons to be remain at the same place. We just want them to resize accordingly, and we want them to be replaced accordingly. Okay, so this is what we're gonna achieve. So with that being said, I hope you guys are excited. Let's get started. So first of all, I'm going to create a new scene here, file new scene, and this is the scene you're going to use. Now for the image, I already have I'm going to use one of my thumbnails from my videos here, and if you take a look at this image is already set at 1280 by 720 resolution. Okay, so we're going to use the 1280 by 720 resolution here. If you don't have a 1280 by 720 resolution set up, you can just click on this plus sign, and here the width you can write 1280, and on the height you can write 720, and by that you will create a resolution like this. Okay, so next what you're going to create is that for the image of the menu, instead of adding a sprite directly, what you're going to be doing is we're going to be using a UI image. Okay, so what's an UI image? So I'm going to create UI, and then I'm going to click on image. Okay, and as you can see, whenever we have created an image, a canvas has been already created for us. So this canvas is the parent of everything, and this holds all the UI elements inside it. Okay, now as you can see in the scene view, we cannot see the image. So in order to see the image, we can select the image and then keep our mouse on the screen view, on the scene view, and press F key on your keyboard. By pressing F key, it will focus on the image. Now you can see that the image is out of the canvas. This is the canvas and the image is out of the canvas. So that is why we cannot see it in the game view. What we can do is by selecting the image from here, if we select the gear icon and from there if we select reset, so what this will do is this will reset the position and this will position it at the center. So now it has been resized here. So now what we can do is by selecting the image, we can from here as the source image of the UI image, as the source image of the UI image, we can select the sprite that we have already imported. If you haven't imported any sprite, you can import any sprite and make sure to make it the same resolution as you want your game to be. In this case, I have used 1280 by 720 resolution. So select the image, click on this source image, and as a source image, you can use this one. Okay, so as you can see, as the source image, we have used this, and now it looks like this. Now what you're going to be doing is from the image, you can see here we have an option called set native size. So what that will do is set native size will make it the original size of the image. So since the size of the image is 1280 by 720, so this will make the size of this UI image 1280 by 720 if I click on set native size. So let's click on that, and if I click on that, oops, I had to do something else before this. So let's press Ctrl Z and let's do something else before doing all this stuff. Before doing all this stuff, what we have to do is we need to set the canvas so that it gets resized according to the screen size. Okay, since the canvas is the main UI element which is holding everything, so we need to set it up first before we do anything else. So we're gonna need to select the canvas, and from here you can see we have a canvas scalar component attached to the canvas. So by using this canvas scalar component, we're gonna do something so that the canvas get resized every time we add UI and we use it in a different screen resolution. So what you're going to be doing is here we can see UI scale mode, and the UI scale mode is set as constant pixel size. Now if it is set as constant pixel size, then the UI element will always be of the same size. As you have seen in the video that whenever we looked at the first scene, at that place the buttons were the same size even if we resized the screen, but we don't want that. So if constant pixel size is set as UI scale mode, then the buttons will be of the same size no matter whatever the screen size is. But we want the buttons to be resized whenever the screen is resized. So that is why we're going to select scale with screen size. So if we select scale with screen size, what that will do is that will just scale our image or scale our UI elements according to the screen size. And here you can see we have one more thing that's called reference resolution. Reference resolution is the resolution which we're going to use as a reference for this. So since here we are using 1280 by 720, so we want our original scale to be 1280 by 720. So that is why we're gonna write 1280 by 720 here. So this is our reference resolution. And down below we have one more thing that's called screen match mode. And we're gonna take a look at this a few minutes ago. I'm sorry, we can take a look at this later. So with that being done, since we have done that, so now let's go and select the image, and as the source image select this one, and now we're gonna click on set native size. Now as you can see, now it works since we have set up the canvas as we want. So now if we click on this image as set native size, it will be set as its full size automatically. So the image will be set at its full size automatically. Now what we're gonna do, we're gonna create the UI buttons. So I'm gonna create UI button, and let's zoom in a bit and resize. Let's place the button here, make it a big make it a bit bigger. Yeah. And from here, from the color, we're gonna select any one color you can select. I'm gonna select the yellow color, okay, this one. And after that, I'm gonna right click, duplicate. So we have a new button, and I'm gonna place that button right here. Okay. And I'm gonna create one more button by right clicking and duplicating, and I'm gonna place it right here. So now we have 3 buttons, and as I have said that we want all the buttons to be resized and stay at the same place wherever they are. So one more thing we need to do for that is we need to set an anchor for the buttons so that the buttons stay at the same place or at the same distance of a screen from the place. So as an example, for button 2, we want this button to be at this position, whatever may be the screen size. We want it to be this units far away from this edge right here. So we want it to be this units far away from the left edge. So we will set its anchor position at the left so that it stays anchored to the left. So what we can do for that is we're going to select the button, and from the rect transform component we're going to select this one, and from the anchor presets we're going to select this one, left middle. So as you can see, it has been anchored to the left middle. Now whatever will be the screen size, it will be always same units apart from the left screen or left end. And for these 2 buttons, this button 1 and button 2, I'm going to select both of them by using control. You're going to select that, then press control and select this one. And for both of these, we're going to select the anchor position at the right middle. Okay. And if we select the anchor position at the right middle, then both of them will be at the same distance apart from the right middle of the screen. Okay. So now we have done most of our work. So as you can see that previously we had issues with this, but now since we have done all the things, now if I just resize the screen, as you can see the buttons are getting resized as we are resizing the screen. Okay, so we have pretty much achieved whatever we wanted to achieve, but there's one more thing that I'm going to talk about. If I make this, as you can see, it is in what I can say that it is in landscape mode. Yes, that's the correct word. So it is in landscape mode, and if I make it in portrait mode, suppose I'm gonna make it in portrait mode by selecting this 480 by 800 resolution or any resolution you want. As you can see that it just gets resized like this. Okay, but why does it resize like this? As you can see here, it is getting the whole width. The width is the same. The width stays same as the previous one, but the height gets reduced. As you can see, the height gets reduced. So why this happens? Why the width only get reduced? If I select the canvas, and from here you can see from the canvas scalar component, here we have a match property. And as I have said that I will talk about it later, as the match property we can select, from the match property we can set how much we want to change it according to the width and height, according to the change of width and height. As you can see here, the switch is towards the width, so that means whatever be the screen resolution, it will always match the width. Now if we wanted to match the height always, so we can drag it here, and as you can see here it matches the height no matter whatever it is. So if we make the width, then the value is 0. If we match it with the height, then the value is 1. But in most of the cases, we want it to be in a place where it will be equally matched to the width, as well as it will be equally matched to the height. So in order to do that, we're gonna place it at the middle or make the value 0.5, that is half. So now it will be equally matched to the width as well as equally matched to the height. whenever it is made portrait or whatever. So most of the times we want to do something like this whenever we need to make the UI for landscape and portrait both modes. And it's always a good idea to match it to parents width and height both. Let's make it to the original size. So probably you guys understood whatever I wanted to say. I just wanted to keep it as simple as possible. I don't know how much I have done that. So I hope you guys enjoyed and learned something. This is going to be very, very helpful whenever you're going to build games for various resolutions. And this is really very important. So I hope you guys enjoyed and this helped you a little. So thank you very, very much for watching this video. If you enjoyed, make sure to subscribe and like. And if you have any questions, just write those in comments below. More tutorials are coming soon. Thank you very much. Have a great day and see you in another video. Hey everyone, welcome to Charger Games. My name is Raja and this is another Unity Android game development tutorial. So in this video we're gonna learn about how to detect swipe in your Android device. So we're gonna basically learn how to detect touch swipe controls in Unity in Android. So I'm gonna try to keep it very, very simple for you, and I'm gonna try to explain each and every line of code. So before starting out, let's take a look at what you're gonna be building at the end of this video. So as you can see here, I have a sample scene, and if I play it right now, and if I go to Window, Console, and right now I have my mobile device attached to my computer by using the Unity remote. And if you don't know how to set that up, make sure to check out my video on how to set up Unity remote and how to detect touches. Okay. So now my device is connected with my computer by using USB, and now you can see that if I swipe my finger up, it will say vertical swipe. If I swipe left, it will say left swipe. If I say right, it will say right swipe. If I say down, it will say down swipe. Okay. So this is pretty much what we're going to be doing first. And then what you're going to do is, then we're going to simply put another quad as our player. And when we swap vertically, what we will do is the player will jump. So let's say I swap vertically. As you can see from here, I have swiped vertically, and as you can see, our player jumps. So again, I can do that and our player will jump. So we'll do that all this from scratch in this video. So with that being said, let's get started. So I'm going to quickly open a new scene. So File, New Scene, and don't save. And I'm going to quickly save this scene. File, Save Scene. And I'm going to go to Save Scene As, and I'm gonna name this scene Swipe, and just save it. Okay, so next what you're gonna do is I'm gonna create an empty game object, and I'm gonna name it Swipe Tester, and add component, new script, and I'm gonna name it not swipe, swipe of, I don't know what happened, swipe test, create an add, and then I'm going to double click to open it in Mono Develop. Okay, so it has opened. And before doing this, make sure you go to File, Build Settings, and change your device, change your current platform to Android. Click on Android and click on Switch Platform. And that way we will have our current platform as Android, and it will help us to test. And from here, from the size, you can select this WVGA portrait because we are testing it in portrait mode. Okay, so now let's start our scripting. Now this will probably be a little bigger because I will try to make it simpler for you, so that is why I will be declaring more variables. So that is why it will be a little bigger. So first of all, what do you need? First of all, we need some time. So let's say the basic two things we need is time and distance. Okay. So what this time will do? The time will check for how much time we have swiped. Let's say we have touched our finger on the mobile device and then we lift it after a few seconds. So a swipe shouldn't be that big. You are not going to swipe your finger for 1 minute or 30 seconds. You're gonna swipe for, let's say, 0.2 seconds, 0.5 seconds. So swipe should be fast, otherwise it won't be a swipe. So what you're gonna do is we're gonna check the starting time when we are touching our device and the ending time when we are lifting our finger from our device, and we're gonna check if the time is less than our maximum time, only then we're gonna detect swipe. Okay, otherwise not. So we will have a max time beyond which we will not detect it as a swipe. Okay, so we're gonna create a public variable named public float max time, and then we're gonna create another public float variable, and this variable will be our minimum distance. So public float min swipe distance. So there should be a minimum value after which we detect it as a swipe. So let's say I touch my finger on my mobile device and I just lift it at that point. So I don't move my finger, I move my finger slightly and then I lift it, but I don't want that to be detected as a swipe. So for our touch to be detected as a swipe, we need to move our finger a minimum distance, and that's gonna be our minimum swipe distance. Okay, so now two more variables I'm gonna detect as float, and this is gonna be our start time, and float, and this is gonna be our end time. So this will be our start time when we touch the finger, and the end time will actually check when we lift our finger from the screen. And then another two we're gonna detect as vector3 start pose, where we actually touch our finger at the beginning, and vector3 end pose. So when we lift our finger from the device, this will be the position of our finger. Okay, so start pose will be the starting position and end pose will be the ending position when we lift our finger from our Android device. Okay, so now we need to check all of this in our update. Okay, so the very first thing we need to do in update is we need to check if we have touched any of our finger in our Android device. So to check that, we're gonna say if input dot touch count is greater than 0, that means we have at least one touch on our screen, only then we're gonna detect all this. And if you don't know about this, you should definitely check out the third video in this series, which is Unity Android touch input controls, and that's gonna be very, very helpful for you. Okay, so when the touch count is greater than 0, then what you're gonna do is, since we will check for only one touch, we are not gonna check multiple swipes, so we don't need to check for multiple touches. So we're gonna need to check only one touch, and that's gonna be our 0th touch. Okay, so we're gonna store that 0th touch inside a variable, and that variable will be of touch type. So I'm gonna say touch equals to input dot get touch 0. So we are getting the 0th touch, that means the first touch that is touching our device, and then we are storing that inside our touch variable. Okay, so now using this touch variable we can actually check everything that we need. Okay, so let's see what we're gonna check first of all. So first of all, we're gonna check the phase of the touch. So we're gonna check if touch dot phase equals to touch phase dot began. That means our touch has just began. That means we have just put our finger on the screen. And we're gonna also check else if touch dot phase equals to touch phase dot ended. That means we have lifted our finger from the device and our touch has ended. So this will be when we just touch on our screen, and this will be when we lift our finger from the screen. Okay, so when we touch our screen, at that time we're gonna get our starting position and the starting time. So the start time will be equal to time dot time. So when we are touching our device for the first time, at that time we are checking the time and we are storing that into our start time. And our start pose will be equals to touch dot position. Okay, so when we are first time touching our device, at that time we are storing at our starting time, and the position we are touching, we are storing that as our touch position. Okay, so next we're gonna check, and next we're gonna check the same thing when we are lifting our finger from the device. So when we are lifting our finger from the device, at that time our end time will be equals to time dot time, that means the time at that time, and our end pose will be equals to touch dot position. Okay, so this is how we are getting the starting time and our ending time basically. Okay, so now with these things, with this data, we can do whatever we want. So what we need to do next is we need to calculate the distance between these two touches, and then we need to check the direction of the touches. Okay, so here let me create another variable and call that float swipe, not swipe t, swipe distance. So inside that we will store our swipe distance, or how much we have swiped. So to calculate the swipe distance, we'll basically say our end pose minus our start pose dot magnitude. Okay, so this will give us distance between 2 points. So if you remember some algebra or mathematics or geometry, whatever, you know that to detect the distance between 2 points, you need to do like x2 minus x1 minus x2 minus x1 and root over and whole square and all that stuff. So this magnitude does all that for us and gives us the distance between 2 points. Okay, so now we have the distance between 2 points. So we need to check now, and one more thing we need to do is we need to now check the swipe time. So let's make another variable, float swipe time. Okay, so now we have two necessary components that we wanted. So now we have the distance, and we can also calculate the swipe, not swipe t, I don't know why I writing swipe time. Swipe time equals to our end time minus our start time. So now we know the distance and the time. So only thing we need to do now is to check if our swipe time is less than our minimum swipe time, or whatever we named it. We named it our max time. Sorry, less than our max time, and our swipe distance is greater than our minimum swipe distance. So if the time is less than our max time that I have explained at the beginning, and our distance is at least greater than our minimum swipe distance, only then we're gonna test for the swipe. Okay, so then we're gonna call a simple function that is swipe, not swipe time, swipe. And now we're gonna create this function right here out of the update function, of course. So here we're gonna say void swipe, and this is our swipe function. So inside this swipe function we need to do all the things that we need. So what's the first thing that we need to check the swipe? First thing we need to do is we need to actually check if it is a vertical swipe or if it is a horizontal swipe. Okay, so in order to check that, as you can see here, we have the swipe distance. The same way we need to get the swipe actually get the difference between the 2 points. Okay, so to get the difference between the 2 points, let me create a simple vector2, and I'm gonna name it distance, and inside that I'm gonna store our end pose minus our start pose, and this time we don't need any kind of magnitude because we are just getting the distance. So now we need to check if the vertical swipe distance is greater than the horizontal swipe distance. So if the vertical swipe distance is greater, then it will be a vertical swipe, and if the horizontal swipe distance is greater, then it will be a horizontal swipe. Okay, so we need to check if our distance.x is greater than our distance.y. So this is basically the difference between the two touch points. So if the x distance, that is our horizontal distance, is greater, then it will be a horizontal swipe, and if our vertical distance is greater, then it will be a vertical swipe. Okay, so if distance.x, that is our horizontal touch distance, and we need to get the absolute value from this, so we need to write mathf.abs, and this will give us the absolute value. So the distance may be negative or positive, but we need the positive value always, so that is why we are getting the absolute value. So we will get, so let's say if the distance.x value is -5, we will get 5, and if it is 5, again we will get 5. Okay, so if mathf.abs distance.x is greater than mathf.abs distance.y, so if the x distance is greater than the y distance, then it will be a debug.log horizontal swipe. Okay, now we need to check the same thing, so let's copy it and paste it here. So now else if the distance.x is less than the distance.y, then it will be a vertical swipe since our y distance is greater. Okay, so now we pretty much have the basic code to check the functionality of horizontal or vertical swipe. So let me go ahead and go back to Unity and plug my mobile device to Unity remote, and let's see if it works or not. So if I run it, okay, so it works. So I'm gonna go to Window, Console, and now if I swipe my finger up, oops, it doesn't say anything. Okay, so first of all we need to give the max time and max swipe distance values. I forgot to add that. So for the max time we'll give 0.5 seconds since we want our swipe to be very fast, and our swipe minimum distance should be around 50. I think 50 should be good. So now if I run it, if I swipe my finger up, it will say vertical swipe, and if I swipe my finger on the sideways, it will say horizontal swipe. Okay, so now one more thing we need to do is we need to check if our vertical swipe is actually up swipe or down swipe, and if our horizontal swipe is actually left swipe or right swipe. Okay, so we're gonna do that. So to check that, we're gonna say, so here you can see here we have our x value, and we need to check if this distance.x value is positive. If it is positive, then it is a right swipe, and if it is negative, then it is a left swipe. Okay, so we're gonna say if distance.x is greater than 0, that means if it is positive, then we're gonna write debug.log right swipe, and the same way I'm gonna copy it and paste it. If it is less than 0, then it's gonna be a left swipe, In the same way, I'm gonna just copy it and paste it here. So same way, our distance dot y, if it is greater than 0, then it is up swipe, and if it is less than 0, then it is down swipe. Okay, so now we have pretty much the working code. So let's go to our Unity and check out what I have done or what errors I have done. So let's run it. So now if I swipe my finger up, it says vertical swipe, up swipe, down, vertical swipe, down swipe, left, horizontal swipe, left swipe, right, horizontal swipe, right swipe. Okay, so we have pretty much done the basic functionality of this thing. So now the last thing we want to do is we want to create a character and we want to check our swipe control on that. Okay, so we're going to quickly create a character. So I'm going to create 3D object quad, and this quad is going to be our character, and I'm going to quickly select the quad and reset the position. Okay, and I'm going to delete this mesh collider from it. So remove component mesh collider, then I'm going to add component physics 2D box collider 2D, and then add component physics 2D rigid body 2D. Okay, so now I'm gonna right click and duplicate this quad, and this time after duplicating I'm gonna, okay, where is that from our game view? So I'm gonna again reset its position. Okay, so here it is. So this time I'm gonna move it down and I'm gonna scale it up a bit. Okay, so now I'm gonna create light, directional light, and increase the intensity a bit so that it looks good. And from the second quad, that is the quad in the down, we're gonna remove this rigid body 2D component because we don't need here. So now if I play, this just falls down. So what we want is when we just swipe, we want it to jump and then return back. Okay, so select this quad and I'm gonna add component, and for it, okay, so make sure to select the first quad, not the second one. I mistakenly select the second quad. So select the first quad, go to add component, new script, and write player move or player jump, whatever. Let's say player jump. Create an add, double click to open it in mono develop, and it will take ages to open. Okay, so here's our player jump script. So here we have our rigid body 2D. So in the player jump script, we're gonna quickly get access to this rigid body 2D. So first of all, I'm gonna create a public, not public, let's make it rigid body 2D, and I'm gonna name it RB. And inside start, I'm gonna say RB equals get component rigid body 2D. So this will give us access to this rigid body 2D, and then what you're gonna do is I'm gonna create a new function called void jump, and in the jump function I'm gonna add a force to this rigid body. So I'm gonna say rb dot add force, and I'm gonna write new vector 2, and for the x value I'm gonna give 0 because I'm not gonna give any force in the x position. And for the y value, let's make a jump force variable that we haven't created yet, but we're gonna create soon. So jump force and end it. So here I'm gonna create quickly a public float, and I'm gonna name it jump force. So this is the jump force by which our character will jump. Okay, so now only thing we need to do is, okay, we can give our jump force later, or let's give the jump force around 400. Okay, so this is our jump force. So now the only thing we need to do is, from the swipe tester, we need to get access to the player and add a jump to it. So let's move back to the swipe test script, and at the top I'm gonna create a variable public game object player. Okay, so if I go back, now you can see, okay, I forgot to give a semicolon. Oh, silly me. So now save it, and if I go here, as you can see, now we have this slot where we will drag and drop our first quad as a player. So drag and drop it here. Okay, so now we have access to the player. Now what you're gonna do is, in the swipe function, when we are doing the vertical swipe, here we are doing the vertical swipe and up swipe. So while doing up swipe, we will say player dot get component player move player jump. So we are getting the player jump script component from the player. Okay, if you take a look at the quad, here we have this player jump script, so we are getting access to that. So we are getting the player jump script, and from there we need to call the jump function. And before calling, make sure to make this jump function public. So let's make it public void jump, otherwise we cannot access it from other scripts. Okay, so now in swipe test.cs, I'm gonna go, and from player jump I'm gonna write dot and jump. Okay, so we are basically accessing the player jump script from the player component, and we are adding the jump. So now whenever we will swipe up, the player will jump. So now let's return back to Unity, and I'm gonna click the scene to play and also make our window console here. So now you will see that I will swipe up, that you can see from here, and the player will jump. So I swipe up, you can see here we have vertical swipe, up swipe, and the player jumps. Up swipe, player jumps, up swipe, player jumps, up swipe, player jumps. And you can use this mechanism to build any game, any kind of game where you actually want to put swipe. And I have just given an example of vertical swipe. You can use the same technique to use horizontal swipe or down swipe or whatever you want. So I hope you guys found this video informative. I know it's pretty long and probably pretty confusing, but I just wanted to keep the code as simple as possible. So that is why I tried to make all these variables so that you guys can understand it clearly and easily. Okay, so if you have any problem, you can just pause the video or rewatch the video or rewatch the sections that you want to watch, and I hope you find it helpful. So thank you very much for watching this video. I love you all. So this is Raja. Thank you very much. Have a great day and see you in another video. So goodbye, and make sure to like and subscribe. So see you later. Hey everyone, welcome to this course. If you wanted to build awesome games and Android apps, you're at the right place. In this course, we're gonna build fully functional games and Android apps from scratch. We're gonna start building our games using Unity game engine. We will get started by building a 3D zigzag game. Then we're gonna build a tappy ball game. After that, we're gonna build a fruit ninja game. Then we will build a 3D flick football game. And finally, we're gonna build a 3D runner game. After that, we will get started building our Android apps using MIT App Inventor. We will start by building a simple Android app and we will run it on a real Android device. After that, we will build a Talk My Name app, a drawing app, a voice translator app, Google Voice Search app, and finally, we're gonna build a Bird Smash app. Take this course now and I will see you inside, and we're gonna together build awesome games and apps.